Okay, I think it's starting to record, hopefully. Let me check. Yeah, it's recording, right? Yeah, it's recording. Nice. So, again, just repeat what I said before. This is, we're just doing this tutorial activity that Mike gave to me because during the actual tutorial I didn't do that. We did the review for the quiz first. Oh, by the way, how was the quiz? Anyone want to give me any feedback? It was alright, yeah. I personally I think the quiz was relatively easy. Especially the first question was relatively easy. I thought he was gonna give you like a harder induction question, but well, we'll see. I just started to mark, and oh, you thought it was easy too? Oh, nice, nice, nice. That's good. If you thought it was easy, then that's good. Fibonacci numbers. Yeah, I thought he was gonna give you Fibonacci numbers as well, but well, I guess he was being nice. I kind of have a feeling that he wanted me to mark easily, but 1.2 was easy though. Okay, I feel like I was kind of intimidating when I say things are easy, but when I say it was easy, what I mean is that you should think it was easy, otherwise you are in big trouble. You didn't read the index properly and thought it was 1, not 0. Okay. I started to grade question 1 already, and it doesn't look so good for a lot of reasons. Some people, they are trying to prove 1.2 using induction, but their proof for induction was like kind of wrong, especially like a lot of people, they don't know how to write base case and the inductive hypothesis. As we mentioned many times in tutorial, I think everyone should be able to do that, but seems like a lot of students are still making those kind of mistakes. So I hope none of you did that. I thought n plus 1, but it was n. Oh, okay. Well, we'll see what happens, and hopefully I can give you partial marks. Sure, sure you did it wrong anyway. Well, I can't comment right now, but we'll see. Hopefully I can give you some partial marks, not 0, because that question actually worth a lot. Yeah. Anyway, let's just start with this tutorial. As I mentioned before I start to record, this part of the course is really, really, really important. Without a thorough understanding of this chapter, you cannot survive the next chapter, which is cardinality. I personally think cardinality is the most challenging part of MAT102, so make sure you understand this part. Again, I'm staying here for long because I hope no one leaves here with any question. So please, please, please ask me any question if you have one, okay? Okay, let's just talk about the learning objectives. So by the end of this tutorial, you should be able to identify a function that is not injective and then find an example why. And well, the same thing for surjective, and then prove general facts about compositions of function from definitions. Well, we'll do that a lot. So basically, this tutorial we're gonna talk about what is a definition of injective, what is a definition of surjection, what is a definition of bijection, and then you should be able to prove them or disprove them. By disprove, we mean giving us a counterexample. So the first activity, if we have a function from A to B, well, this might not be a function actually. If f, the mapping is from A to B, which of the following two statements means that f is injective? What does the other one mean? And I want you to write the contrapositives of both implications. Again, As always, I'll give you some time to think about those, and then we'll take it out together, okay? As always, show me your favorite emoji when you're done, and then I can take it up. But today we have a lot of time, so I don't want to rush through anything. Which tutorial is it? It's tutorial 9, I think. Let me see. Yeah, tutorial 9. So the tutorial from this week 10, tutorial 9. Okay, are you guys done with this question? Do you guys need more time? Good? Okay, we're good, right? Okay, so which one of those two statements is the definition of injection? 1 or 2? Okay, one of you said 1, one of you said 2. Anyone else? Let's add question. Let's vote. Oops. Oh, this looks... Which of the following statements is the definition of injection? Single choice. 1 or 2? Okay. Wait, why is it not working? Okay, I don't know why it's not working, so it seems like it's not... I cannot let you vote. Okay, yeah, I don't think we have one either. It's okay. Well, most of you chose 1. One of you think it's 2. Let's see who's correct, okay? This is awkward because the only person, Eliza, is that your name? Is that how you pronounce it? Eliza? You are correct. Yes, you are the only correct one. The correct one is 2. Congratulations. Yes, correct one is 2. You thought you wrote the definition wrong. It's correct. Okay. 1 is a definition of something, not for injection. Okay? We'll go over this because it's really important. People miss it up all the time. So let's write in red so that everyone knows. This is a definition of injection. What does this mean? Okay, let's have a look at this and we'll talk about it, okay? So this is saying that if we have any two elements from your domain, again, let's just do a short review. This is your domain. This is your codomain. Codomain. Okay? So if you have any two elements for your domain, let's draw a graph. Can you guys hear people laughing? Because I have friends in my house right now. And he's laughing. Anyway, so let me just draw a graph. Like this. Okay? This is saying if you pick any 2 points. Oh, you can't hear them? Okay, that's good. So if you pick any 2 points, let's say this point and this point. Okay, so this is my x1. This is my x2. If you pick any points in your domain, and it's saying that if f of x1 equals to f of x2. Also, I can't really just randomly pick 2. So I need to pick something that they have the same y value. So let's just pick this one. Okay, suppose those are equal. So this is my x1. And this is my x2. Okay, so those are my 2 points. And this is f of x1. This is f of x2. It's saying that if f of x1 equals to f of x2, then x1 equals to x2. Okay? We know that injection means you cannot have you can only have 1-to-1 function. Okay? This is not 1-to-1. This is 2-to-2. Do you guys see that? This is 1-to-2, sorry. Because you have the same y value, but you have 2 different x value. So for each y value, you can only have a single distinct x value. So this is not 1-to-1. So this is a definition of injection. For injection, we have a test about this. Do you guys know what is a test? So you have a graph, you can do a test on the graph to see if it's injective. Horizontal line test, exactly, horizontal line test. So horizontal line test. Okay, just like what I did before, if you draw a line, a horizontal line, if you got like more than one intersection, so now we have 1, 2, 3, then it's not injective. So for injection, we have horizontal line test. Anyone want to guess what's the definition of the first statement? Well, you can see it's really similar to 2. What is the definition for the first one? The first statement, what is it? Anyone know? It's the converse of the second one. Okay, I'll give you a hint. The first one, you can do it with vertical line test. So think about vertical line test. Where did you see that?
The test of whether it's a function.
Exactly. Okay. First one is a definition of a function. Okay, finally I heard someone speaking. This is good. Now I don't feel like I'm talking to myself. Yes, the first one is a definition of a function. The second one is a definition of injection. Why is that? If you look at this, you guys know that for function, you cannot have something like this. So for each x value, you cannot have 2 y values, right? So this is telling you, this statement is telling you that So if you have the same x value, then your y value has to be the same as well. This is quite important, the definition of a function, okay? Not as important in 102, but in future courses, you should know what's the definition of a function, like this correct definition, exact definition, all right? So next question, write the contrapositive of those two. So what is a contrapositive of the first one? And contrapositive, so for what is a contrapositive of the first one?
So the first part will get reversed to there exists an x1 and an x2 that are elements of A.
Okay, hold on. We're talking about contrapositive. Okay, not contradiction, not negation. What is a contrapositive of a statement? If we have P implies Q. Okay, exactly. Okay, so for all x1, x2 in A, if f of x1 does not equal to f of x2, then x1 does not equal to x2. Second one, then f of x1 does not equal to f of x2. Okay? So activity 2. I'll give you a bit time to think about it, and I'll be back in 5 minutes, okay? You guys can talk to each other if you want to, but I'll be back. Right, I'm back. Are you guys finished with the question? Yeah? Okay, cool. So anyone want to give me your A and B, show that those functions are not injective? For the first one? Anyone want to tell me? Yeah. So what is your A? 1, 0 and negative 1, 0. Let me see if it works, okay? So you have, oh yeah, it works. Okay. Anyone has any other idea? Any other example you want to share to us? No? Okay, what about number 2? Number 2, anyone want to share? So basically, you want to find 2 points, two different points, so that they have the same y value. Okay. 1 cosine 1 and negative 1 cosine. Wow. Okay. Yeah, I know it works, but one thing I want to mention is like when we use trigonometric function, we usually don't use degree, we use radius. So you better use like pi, or pi over 2, things like that. Okay, we don't use degree, we only use radius. But well, it works. I know it works. But pi over 2 isn't defined in the domain. Well, you can use pi over 4 and things like that. Pi over 3, pi over 6. Right? Yeah. Okay, so let's use power pi over 4 then. Pi over 4 and negative pi over 4. How's that? So A is, do I need points or just actually, is it? I think they're just asking for x. Yeah, so B is negative pi over 4. Yeah, they're just asking for x. So this one will be like 1 minus 1. Don't need y. They're just asking for x. Number 3. Anyone has a 1, 3? Yeah, sure. So we can have A equals to 1, B equals to 3, or, well, you can just put any, as long as both are even or both are odd, then you are fine, okay? So you can have like 2, 4, 1, 9, something like that. Any question for this one? No? Okay, this should be clear. Activity 3, give specific points y the codomain of those functions show that those functions are not surjective. Okay. Wait, so do you want to just unmute yourself, Danny?
Oh, yeah, sure. So will every even function be not injective, given that like its domain is like entire domain is defined?
Wait, repeat that again?
So will every even function, given that it's defined on its entire domain, will not be injective? So like cos x, for example, where the domain is any real numbers or x squared.
Yeah. If the whole domain is defined, yeah, then yeah, because like it's metric
Okay, cool.
y-axis, which makes it
Okay, cool.
Okay. Anyone want to give me an example for question 1? So you want to show that it's not surjective, which means you need to find a point in the codomain such that this function cannot be mapped to. Okay. Recall the definition of surjectivity.
0.
Y equals to 0. Okay.
Yeah, for the first one.
So if we have y equals to 0, since 1 over x squared is always greater than 0, it can never reach to 0. Yeah. What about number 2?
-1.
Y equals to, again, let's just use, okay, whatever, it doesn't matter. Let's just say y equals to 2. Okay. Someone said y equals to 2. Let's use 2 then. Why is that? Why can it never reach to 2? Anyone? Why is it? Okay, because cosine can only be between 1 and -1. Exactly. Okay, because cosine x is smaller than 1. No, not smaller. It's greater than or smaller than or equal to 1. So it's smaller than 2. Okay? For all x in this domain. All right, number 3. Yeah, that works too. So there are a lot of other examples because we have R here, right? So let's say you can pick like 100 or something. Number 3. Okay, y equals to 0. For the student who unmute yourself, can you explain why y equals to 0 would work? Okay, Maxine says, yeah, exactly. So you list out the image of the function already because h of natural number is -1 and 1. So the only 2 values that it can map to is either 1 or -1. So if you pick any other number, it's not going to be mapped to. Okay, so it's not surjective. Any question about this?
I had a quick question for this part.
Yeah.
So to prove that it's not surjective, can we just prove that it's injective? Like, or do we have to find a value that it doesn't map to?
Okay, injective and surjective are two different things. If a function is injective, it doesn't mean it's not surjective. They are
Okay.
separate, okay? They are completely separate. What you are saying is that, well, if we ask you if a function is not bijective, then you can show it's either not injective or surjective. But injection and surjection, they are separate. It doesn't mean like, oh well, if it's not injective then it's surjective. It doesn't work in that way. So the only way to show that a function is not surjective is find a point that's in its codomain but can never be mapped to. Does that
Gotcha.
make sense? Okay,
Okay, thanks.
no problem. Okay, any other question? Okay, seems like we have no question. Let's move on to the next activity. So this is a review from your problem set 3. Mike wants you to show that there are 8 different functions with a domain 1, 2, 3 and codomain 0, 1. Okay, again, I'll give you a bit time to think about it. And then we'll do it together. I don't think any one of you know combinatorics, like counting. So the best way to do it might be just list them up. List all 8. But if you do know counting, then you don't have to. What do we need to count for? Oh, you need to count how many functions are there with domain 1, 2, 3 and codomain 0, 1. Well, he gave you 8 already, but you need to show that. Okay, you need to show there are 8. What was the last one on the previous slide? Okay, I'll show you the previous slide here. It's not 3 choose 3. So I'm not asking you to use combinatorics to do this. I'm asking you to list all 8 out, okay? All 8 different functions out. So let's do this. Let me just use since our domain is 1, 2, 3, let's say our function is f. Map from 1, 2, 3 to 0, 1. Okay, so let's denote our function. So the function can be written as function can be written as f of 1, f of 2, and f of 3. So let's use this notation to write all the functions, okay? So what does this mean is that, for example, if f1 equals to 0, f2 equals to 1, f3 is 0, then we call this function 0, 1, 0. Okay, in this way, and I'm asking you to list all 8 different functions, okay? We'll list them out and then I'll talk about the counting, the combinatorics ways to do it. But for now, let's list all 8 out. Well, now I have 0, 1, 0. What else do I have? Okay, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1. We need one more. 0, 0, 0, exactly.
But I think you have 0, 1, 0 twice in the list.
Do I?
Yeah.
Oh yeah, I do.
First element and the third element.
So we're missing one more. What's the last one? 1, 1, 1, exactly. Let's write it here. Okay, so this is like the brute force way to do it. The other way, if you know combinatorics, or even if you don't know combinatorics, I'll explain how you do it. So for each of the domain, so we have domain 1, 2, 3. 1, 2, 3. You can map to either 0 or 1. Which means for each of the elements in your domain, you can either map it to 0 or 1. Which means for each of the elements in your domain, you have 2 different choices. Okay? So for each one, you have 2 different options. For 2, you have 2 different options as well. For 3, you have 2 different options as well. So in total, you have 2 times 2 times 2 different functions. It's like a binary string. Different functions. Okay, so that's another way to do it. Any question? Yeah, 2 to the third methods, exactly. Question? Makes sense. Okay, nice. Any questions? Do we have any questions? Okay, seems like no questions. That's good. Okay, move on to next activity. Show that there are 6 different surjective functions with domain 1, 2, 3 and codomain 0, 1. So last activity we were asking about functions in general. In this activity, we're talking about surjective functions. So remove 1, 1 and 0, 0, 0. Exactly. So everything works except those 2. Okay, let me just copy the list and remove those 2. So, oops. Everything but 1, 1, 0, 0, 0. Okay. The reason is that for those 2, you cannot map to the other one. So for this one, you don't have 0 in your image. For this one, you don't have 1 in your image. Okay, so they are not surjective. Any other question? Does this make sense to you? Okay, seems like everyone understands this. Okay. Show that there are no injective functions with the domain 1, 2, 3 and codomain 0, 1. No injective function. Why is it impossible to have injective function with the domain and codomain?
So because we have less elements in the codomain, and as opposed to the domain, at least one, not each x value will have a unique value in the codomain.
Why is that? You're right. We have less elements in the codomain, and you said, well, they can have unique. Why is that?
So let's just say that we just do like 1 and 0. Like if you try to just pair them into each, I don't know how to explain it.
Okay, the reason I'm asking because you learned something that you can apply directly, okay, from your problem set. It's something new, you never learned in lecture, but you saw it in your problem set. And you were tested on your quiz as well. It's a principle. It's about bird.
Oh, the pigeonhole principle, yeah.
Okay, yes, by pigeonhole principle, okay? So this is impossible.
Are we allowed to just freely refer to these principles whenever we find them relevant then?
If they introduced it in your problem set, then you can use it directly.
Okay.
Yeah, like pigeonhole principle is really useful, I would say. We use it all the time. It's impossible because there are more elements in the codomain. Okay, so by pigeonhole principle, one of the choices must be repeated. Okay, so my next question, it's not here, but my next question is, can we tell, okay, no. Let me think. So if we look at the size of the domain and the size of the codomain, is there a way that we can tell that it's never gonna be injective? Is that possible to see that, well, it's not gonna be injective? Can we tell by the size of the domain and codomain? Is this possible? So I'm trying to generalize this question here.
So isn't this the issue where anytime the codomain is going to be smaller than the domain,
Okay,
it's possible to have an injective function?
so if the size of codomain is smaller than the size of domain, okay, then the function can never be injective. Okay, this is really useful, especially in the next chapter, okay? When we talk about cardinality, this is really important. I don't think you can use it directly, but again, as I mentioned before, it's really easy to prove it by using pigeonhole principle directly, right? So it's useful, so please know this. But if you're gonna use it, then add one more sentence, by pigeonhole principle, blah 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 blah. Okay. Any other question? Question? Do we have any question? Okay, no? Okay. I want to write down another statement and I want you to think about why it's true, okay? So again, it's generalization, and instead of injection, I'm going to talk about surjection here. So if the size of domain is bigger than the size of codomain, then the function can never be surjective. Okay, so I want you to think about this statement and tell me why it's true. Wait, did I wrote it wrong? Oh yeah, I wrote it wrong. It's smaller here. Sorry guys. I basically wrote the same statement twice. Yeah, so I'm talking about the domain is smaller than the size of codomain. Yeah, I read it and I was like, oh, it doesn't make sense. Yep. So I'm talking about the size of the domain is smaller than the size of the codomain. In that case, our function can never be surjective. Why is that? Anyone
So
want
there
to talk?
aren't enough elements in the pre-image to cover off every element in the image.
Did you guys know pre-image in lecture? Because I'm not sure if we're allowed to talk about pre-image because usually it's not covered in lecture. Okay, I got no answer.
The term has been used.
It has been used. But Jordan said you didn't know it. Never heard of it. Okay, so let's say we can't use the word pre-image. Let's just use domain and codomain.
Well, another way to say it would just be that you don't have at least one, like since the domain is smaller than the codomain, you won't have at least one of the domains that maps to the codomains because there's not enough of them.
Okay, exactly. Okay, so since the size of the codomain is bigger, and we know that by the definition of function, one x cannot be mapped to two different y, right? So we know that at least one element in your codomain that can never be mapped to. Okay, so that's the idea. Again, those two statements, they are really useful, but they were never proved in lecture, so that you cannot use them directly. But since we explained it here already, it's really simple to explain why it's true, and it's really simple to prove why it's true, okay? We can always use like pigeonhole principle, okay? So I'm not gonna write a formal proof here, but if you understand what we're saying here, it should be easy for you to explain it, okay? Any other question?
So then the extension of this is a function can only be bijective if the codomain and the domain are the same size.
Exactly, okay? Exactly, that's correct. I did not extend it because we will talk about it in the next chapter. So I'm trying to give you a preview of the next chapter. But exactly, you are right, okay? A function can only be bijective when its domain and codomain have the same size. Exactly, okay? Any other question? No? Okay, cool. So, next activity. Generalize the 3 previous exercises to functions with domain 1, 2, 3, 4 to 10 and codomain 0, 1. Okay, last 3 exercises. Let me see what are the exercises are. Oh, they want you to show, first of all, the first question is, how many functions, okay, are there with domain 1, 2 to 10 and codomain 0, 1. Well, this time I don't think you want to list them out. So use the counting way I taught you earlier. Number 2, how many surjective functions? Again, with domain less and codomain less. And the third question is, show that there are no injective functions. With the domain and codomain. Okay? So, the first question, anyone want to answer? Oh, okay, so you guys got it already. It's 2 to the 10, exactly. 2 to the power of 10. So it's the same idea as we mentioned before. For each of the elements in your domain, you have 2 options, either map to 0 or 1. Okay, so it's 2 times 2 times 2. So it's 2 to the power of 10. Number 2, what about number 2? Okay, one of you said 2 to the power of 10 minus 2. The other one said minus 10. Okay, think about it. Both of you think about it and decide which of you is correct. Well, we know that we need to minus something. So count how many of those functions are not surjective. Minus 2, yes. Okay? Yes, only with all zeros and only with all ones are not surjective. Okay, makes sense? Oh yeah, cool, cool. Number 3. Well, number 3, it's the same idea right here. Okay, so copy paste. I hope I don't need to explain it again. Okay, but if you don't understand, ask me now. Any question? Well, I guess this activity is not challenging at all. Question? Okay, seems like we're fine. What was the second one again? Second one, oh, so second one is with -2, okay? Because there are only two functions that are not surjective. One is like when all of them are mapped to 0, and the other one is when all of the elements are mapping to 1. Okay, does that make sense? Every other functions are surjective, so you're -2. Okay, cool. Any other question? Okay, seems like we have no question. Let's move on to the last activity. So let A be 1, 2, 3, B be 4, 5, 6. For each condition, give an example function fi from A to B and gi from B to A with the following properties, or explain why it is impossible. Okay, so let's look at number 1. Number 1 is saying that G1 is the inverse of F1. Is this possible or not possible? G1 is the inverse of F1. If it's possible, then give me an example. If it's not possible, tell me why. Y equals 2x plus 3. Okay, so let's see. Is that your G or F? And f of x equals to x plus 3. Okay, what about your G? What's your G? Oh, oops, this is G. Inverse of that will be what? X. X minus 3. Yeah. Exactly. Okay, so for people who don't understand, well, F is gonna map from 1 to 4, 2 to 5, 3 to 6. And then your G is mapping from 4 to 1, 5 to 2, 6 to 3. So you see that they're inverses of each other, okay? Number 2. Is number 2 possible or impossible? I guess the same F and G from 1. So you're saying it's possible? think again. It's not possible. Yeah, it's not possible. And I want you to tell me why. Why is it not possible? Okay, think about this. Look at this. We do G first. So this is gonna map. G is mapping from B to A. So this is gonna map from B to A. Okay, and then F is going from A to B. So go back to B. So this whole thing, the domain is B, codomain is B. For this, you do F first. So F is gonna map from A to B, and then G is mapping from B to A. So the domain and codomain of this are both A. Now can you tell me if it's possible or not? Are they equal? They're definitely not equal, right? Can we also use a counterexample? In this case, you cannot use a counterexample, okay? The reason is the following. Because we're saying that it's not possible. So unless you list out all the possibility, which in this case, that's a lot of work, okay? It's better to say that it's not possible because they have different domain and codomain, okay? Because it's not, it's really, I don't even think you can give me a counterexample because it's not possible to do it, right? Okay. So since we are here already, I want to talk about one thing that's really important. Okay, really important thing. And a lot of people don't know about it, but it's really important. Okay, I'll write it in a square. Oh, this is not a square, a rectangle. I wanted to make it square though. Okay, let's just use it here. So, my question is, what does it mean for two functions to be equal? Let's say f equals to g. What does it mean when we say f equal to g? Okay? What do they mean for two functions to be equal? Anyone want to give me some idea? So I'll give you a hint. There are three things that has to be satisfied in order to claim two functions are equal. Tell me one thing. The function map to the same place. So you're saying they have the same codomain. Is that what you mean? Same codomain, or you're saying that they have the same expression? Which one do you mean? Same expression? Okay, so same expression. Yeah, that's one. So you're saying, for example, if my f is x plus 3, then my g has to be x plus 3 as well. Each output has only one input. That's the definition of function. Okay, so right now I'm talking about the definition of two functions to be equal. Any other suggestion? Same domain, exactly. What is the third one? Same codomain, exactly. Okay. Please, please, please make sure you know this, okay? To claim two functions are equal, they have to have the same domain, same codomain, and same expression. Most people only remember the first one, okay? So when they see, well, my f is x plus 3, my g is x plus 3 as well, but, well, they are equal, okay? You have to check if they have the same domain and codomain. It's really, really important. And I'll give you an example. For example, my f is from R to R with mapping from, okay, let's say x plus 3. My g is from natural to integer and has the same expression x plus 3. Okay? Now, can you tell me if those two functions are equal? Can I say f equals to g? No, right? Okay, another question is my f injective or not? My f is it injective, surjective, bijective, or neither? It's a bijection, right? So this is a bijection. What about g? It's injection, okay? Well, not only because of this, but I'm telling you, even if when you see two functions that have the same expression, that does not mean they are the same function. Really, really important, okay? Please make sure you remember this. Really important, okay? This is just one of the example. Okay, number 3. Let's do number 3. Look at number 3 and tell me if it's possible. Yes, it is being recorded. So if you have anything else to do, you can leave now. It's fine. I will stay here until 5 o'clock for questions, okay? Number 3, is this possible or not possible? It's possible, you think? Okay. If it's possible, can you give me an example? Yes, you're right. It is possible. Okay, it's possible. Anything you can think of? Because B mapped to B. Well, Yasmin, even when, although like they have the same domain and codomain, but it doesn't mean like it can map to back to X. Yes, Eliza is correct, okay? When F and G are inverses of each other, then it's possible. Okay? When F is the inverse of G. For the other people, okay, you are almost there, except you're only talking about the domain and codomain. But okay, what if they are not inverse of each other? So for example, you can have F mapped to from 1 to 5, 2 to 4, 3 to 6, and your G is not mapped to, like, for example, 6 to 3, 5 to 2, 4 to 1. Then the domain and codomain, they are still correct, but they are not inverse of each other, so you can never map back to X. Does that make sense to you? So if we want a specific example, in this case, you can use the same example as in question 1. Okay, since they are Can you guys hear me now? Okay, cool. So I'm just gonna use the mic from my laptop. All right. I was just asking number 4. Do you guys think it's possible or not possible? And if you think it's possible, why is it possible? Number 4. Anyone has any idea about number 4?
Would it be impossible because it's sort of like the previous idea of the codomain is not big enough because it's only 1, but then we say that the range of
Okay.
the first
It
part has to
seems
be.
like no one has any idea about number 4, okay? I'll tell you it's possible. And I will give you my F and I want you to give me my G based on my F, okay? That will be easier, I guess. So let's say F1 equals to 4. F2 equals to 4 as well. And F3 equals to 6. Can you come up with a G such that this is satisfied? Anyone want to share? This is weird. Oh my god. Hello? Oh, now it's working. Okay. So I wrote down F already. I want you to come up with a G so that it's working. It seems like we have a lot of technical issue here. Yeah, I'm okay. I don't know what's going on. Okay, anyone has an idea for number 4, G? So let's just write it down. Fg equals to 1. F6 is 1 and G of 5 is 2. Okay. This is so weird. Yeah, I heard the echo as well. I don't know what's going on now. Can you guys hear me now? Yo, as long as I have one mic on, it's like echoing. This is weird. Let me mute myself. Okay, what about now? Do you guys still hear echoing? Okay, oh, nice. Finally, I sound like an angel. Oh, thank you. Okay, cool. Now, finally fixed it. So, guys, check my number 4 and see if it works, okay? Because I'm not sure if it works. I'm just thinking. Now my F4 G4 compose F4. Let's try it. So F4 1 to 4, 4 to 1. So that's, and then 2 to 4, 4 to 1, 3 to 6. Wait, 2 to 4, 1 to 4, 4 to 1, 2 to 4, 4 to 1, and then 3 to 6, 6 to 1. Wait, I think I made it the other way around. It's not correct. Right? It doesn't look right.
Yeah, I think your G4 composed F4, the way you have it goes to one element, doesn't it?
Yeah, it has only one element now. So let me change it. 1 to 4, 4 to 1, 2 to 4, 4 to 1, 3 to 6. Let's make 6 to 2 and see if it works, okay? So now it has 2 elements. Now let's check F4 compose G4. So 4 to 1, 1 to 4. So that's one element. 6 to 2, 2 to 4. That's one element. 5 to 2, and then 2 to 4. That's one element. Oh, now it's working. Okay, so this is like one example of showing you this is working. You can have many other examples to show that it's possible. Any question? Do we have any question? No? Okay. Number 5. So guys, look at number 5 and tell me if it's possible.
So isn't 5 just a variation of number 4?
They are totally different. It is a variation, but I'll tell you 5 is impossible.
Yeah.
And I want you to think about why. Are we good now? No problem. Okay, 5 is impossible. Anyone know why? Anyone has a guess?
So my intuition is because A and B only have 3 elements each. Decompose F having 3 elements, you've kind of maxed out what's possible. So you're left with very little leeway. The leeway that we had in number 4, because it was only 2 elements or 1 element, we don't have that leeway in number 5. That's what my intuition says.
Your intuition is leading you to the right direction. Okay, so basically, they're telling us the range of G5 compose 5 has 3 elements, but your codomain has only 3 elements. Okay, so what does that telling you? We know that the range is a subset of the codomain. Now they have the same number of elements, which means your range equals to your codomain. Okay, so that is telling us this function is a bijection. Does that make sense to you? Yeah, okay, cool. So this is telling us this is a bijection. Okay, again, I'll repeat the reasoning again. First of all, okay, let's just write down the domain and codomain first. So F is A to B, and then, so this is mapping from A to A, correct? And then we know that the range has 3 elements, but the codomain itself has only 3 elements, which means every element in the codomain is being mapped. In this case, you know, at least it's surjective. Okay, it's also bijective because, like, well, it's mapping from A to A, and each one you can only map to 1, so it has to be 1 to 1, right? So from here we know that this function itself is a bijection function, which means it has inverse, correct? We know that if a function is bijective, then it has an inverse. Are you guys following me? Does that make sense?
Yep.
Yeah, okay. Well, if we know it has inverse, okay, actually, hold on. Actually, that's not what I wanted to say. I didn't want to say inverse. Actually, I mean, this function is a bijection, which means our f and g can only be bijection as well. So this is forcing my f and my g to be bijection. Okay? Because, what's up?
Do you want to eat anything? Or you already all?
Not really.
Okay.
That was my sister. So basically, if you think about it, if one of the function is not bijection, the composition cannot be bijection anymore. So if we know the composition is a bijection, which is gonna force both of the function to be bijection. I'll give you an example and you'll see what I mean here. So for example, since we know we start from f, this is from f. So we have a, b, f is mapping from here to here and then back to a. Okay, so we know a has 3 elements. So let's say a is not injective. Okay? If it's not injective, which means 2 elements might map to the same element. So if f is not injective, this is gonna then f of a, which is in b, can only has the size of this, okay, has at most 2 elements. So if it's not injective, it's not surjective either, correct? Because if it's not injective, then 2 elements in your domain is gonna map to the same element in your codomain, and then the other one can map only to the another one. So it has at most 2 elements. In that case, even if your G is injective or bijective, you can have at most 2 elements for your range of the whole composition, which means F can only be bijective. Okay? Same idea for G. Let's say if our F is bijective, G is not bijective. Then you have 3 elements here. Okay, if it's not injective, those 2 might map to the same one. Okay, so 1, 2, 3. Then at most you have like 2 elements for your range of the whole decomposition. So since we know the composition is bijective, which forced both functions to be bijective. So in this case, we know that F is bijective, G is bijective, which means their composition has to be bijective as well. So the size of the range would be 3 as well. Wait. The size of the range of the composition is 3 as well. That's what I meant. So this has to be 3. Does this make sense to you? So I'll repeat again. The range of this. So the first half sentence is telling you that the composition is a bijection. Okay? Because the composition is a bijection, that is going to force both of our functions to be bijection. Okay? So since G and F are both bijection, this composition is bijection as well, which means the size of the range has to be 3 as well. Make sense? Question? Question? Makes sense? Okay, nice. I know this part is slightly confusing. That is why I suggest you to read my tutorial from winter. Okay? Read the last 2 pages and it should make sense to you. Okay? What I mean is this. read, I uploaded this file on Quarkus as well. So read not the first few pages, but the last 2 pages. Those 2 pages, okay? Read those 2 pages, and it should make sense to you. And it's really, really, really important to understand this part, because composition itself is a bit confusing for everyone, even for a lot of TAs. All right? Where can you find this? Okay, here. So you go to Quarkus, go to Home, Course Modules. Okay? You guys can see this, right? Yeah,
Yep.
okay. And then go down, go down, go down, go down, go down, go down. Here, you see tutorial 0103, 0106 materials, and go to the bottom. This one is the PowerPoint we use today. Okay, see, those are the activities we did today with no solution. Well, because I covered every single question in tutorial already. The last one, this one, is the file I used last semester. So I created this worksheet myself because Marina was a coordinator and she doesn't care what we do in tutorial. So I make my own tutorial worksheet. So if you click this, go to the last 2 pages. Okay, the last 2 pages explained this question, question 4, okay, with a lot of explanation. Okay, I wrote this during one of my office hours before the quiz because I feel like they might be tested on this, and they actually got tested on this. Anyway, those last 2 pages can be really, really helpful, so have a look at those. If you have any question, you can ask me. That is the end of the formal tutorial. I will still stay here until 5 o'clock. If you have any question, you can ask me. Okay, if you don't understand anything from this chapter, please ask me, because as I mentioned many times, it's really important to understand this chapter in order to do well in the next chapter. Okay? No problem. Great. So if you have no question, you can leave now. If you have any question, ask me. You can unmute yourself. It doesn't really matter.
I had a vague question. How do you think we should prepare for the exam?
For the exam?
Yeah.
Okay. Honestly, I've never seen Mike's exam before. The reason is the following. The first time when he coordinates a course, he used all of our hours on working, so we had no hours to invigilate the exam. So when he was coordinating, all the TAs did not invigilate the exam. It was only professors, and I heard it was really a mess because like people were asking questions and they didn't have enough professors to answer their questions. But the thing is, I was never there, and the exam's not posted yet, so I really don't know what his exam looked like. I really have no idea what that looks like. But what I suggest you to do, because I think I know Mike himself pretty well already, is that you redo everything he posted. So you redo your quiz, you redo your problem sets, make sure you understand the idea, not just to understand the question itself, understand the idea behind it. Because what he really likes to do is he really likes to put on variations of tutorial activities, of lecture examples, of your quizzes or assignments. So as long as you understand the idea, you understand the concept behind that, you should be good. Okay? There's nothing else I could say because he really likes to give you new questions to work on. So even if you practice a lot during the exam, you'll still see new questions. So I don't think you'll see anything that you've seen before. What he really likes you to do is apply what you learned in a lecture or tutorial to something new that you've never seen it before. It's more like application of what you learned. Yeah, that's all I can say.
Sounds good. And like before, in one of the lectures, he gave us these sets of questions that were based off of blocks of the weeks of the lectures, and they were just textbook questions. So do you advise that we do those and then to confirm our answers, because there isn't solutions in the textbook, to just go to office hours and then confirm our answers? Like, are we allowed to go with our work and then see if it's right or not? Or
Yes, but I do not suggest that. The reason is that there are a lot of questions and it's impossible for us to cover everything. So I suggest you to do is get into a group of 1 or 2 people. So I know you guys have group chats and Discord groups. So what you can do is you can post your solution there. Okay? I mean, since it's not assignment, so it's not academic offense. So you can post your solution there.
the
Ask
textbook?
your peers to criticize you. Ask them to mark you. Ask them to give you suggestions. That is the most effective way to do, because in that way you can learn from other people's mistakes as well. Okay, you know what I mean? So when you see other people's solution, when you try to criticize your proof, you can see what part they try to make mistakes. So you can compare your answer with your peers, and you can see other people's solution, and you can see where they make mistakes. In that way, you can avoid their mistakes as well. But if there is a question that nobody knows how to do it, then for sure you should come to office hours and ask us for opinions. Also,
Okay.
another thing that I suggest you to do is that for each type of a question, for example, when I say each type, or for example, let's say the proof for image. Okay, so that's a type of question. So how to prove the image of a function is something. That's one type of function. So what I suggest you to do is that for each type of a question, show your solutions to a TA or to a professor in office hour, and ask them to criticize your proof. Okay, because the reason is that because when we mark your problem set or quiz, we see a lot of students, they don't know how to write a proof. They tried really hard, they did a lot of questions, but their proof is just not correct. So I suggest you to do this is that you can always make sure your proof is perfect. So you did everything you need to do. For example, induction. Show one of your induction proof to a TA and ask them to, oh, how do I improve my proof? Like that. So you just need to see one example and you should be good. But I suggest you to do that for each type of a question, because that happens a lot. Like a lot. People don't know what they're doing.
Okay, thanks. I think that's really helpful.
Okay. Anyone else has a question? Let me see if I can do something else to help you. This is induction. I don't think you tutorial 10. Oh, cardinality. Okay. Yeah, so there's nothing really, not much. Yeah, I uploaded this on Quarkus already. I don't know where exactly in the lecture they're covering right now. Do you guys have a lecture today?
Yeah.
Yeah. Oh, what did you guys cover last time in the last lecture?
Mike covered cardinality and countability today.
Oh, when was your lecture? In the morning?
11 o'clock till 1.
Ah, I see,
And then
I see.
the night section with Chun goes from 5 till 7 tonight. I assume he'll cover the same, roughly the same area.
Okay, cool. Okay, so I guess I'll upload this as well. So this is my tutorial slides from last semester. I will upload this on Quarkus so you can have a look once you done cardinality. Yeah. So let me just upload this. I don't think I can do it here. Let me do it here. Okay, I think it's there in a few seconds. So this is a tutorial slides I used last semester, which can be helpful for this semester as well. You can have a look at the content. If you wonder the solution, I recorded this tutorial, so it's on YouTube. So let me just go to YouTube and show you. YouTube. So if you go to YouTube, go to my channel. You should be able to see this right here. Okay, so this is one. For this tutorial, I'm going to talk about. So this is a tutorial I recorded from last semester. So if you want to know, the solution of the questions, you can have a look. Other than that, there's nothing I really need to talk about unless you have anything you want me to talk about. Or if you have any question you want me to go over. Other than that, I did not prepare for anything else. Okay, bye, Yasmin.
Thanks very much. This has been really helpful.
No problem.
See you next week.
See you.